Okay, in this video I want to talk about factoring using the greatest common factor. And in the examples I have, there's another one down there, we're simply just going to factor out the greatest common factor. So again, the greatest common factor would be the largest factor that we could divide evenly into every term. And basically to do this, the way I think about it at least, what's going through my mind, is the first thing is I see that in my first example there are three terms. I see the 2x cubed y to the 8th, 6x to the 4th y squared, and then the 10x to the 5th y to the 10th. So I see three terms, and what I do is I first look numerically. I look at the coefficients. I see a positive 2, a positive 6, and a positive 10, and I think what's the greatest common factor of those three numbers? Well, I believe that would be a 2. And then next what I do is I start looking at my variables. So I notice that there's an x in the first one, also in the second term, and in the third term. So that means I can certainly factor out an x. And then I have to pull out an x to a certain, I have to think to what power. And there's a 3, a 4, and a 5. Basically what you do is you just pull out the smallest exponent. So we're going to factor out an x to the third. Likewise, we have a y, y, and a y, so I'm going to pull out a y. Again, I look at the exponents. There's an 8, a 2, and a 10. The smallest exponent is a 2, so I'm going to factor out y squared. Okay, so now we've pulled out the greatest common factor. So I have to think what would go back inside the parentheses so that when I multiply things out, I get what's above it. If you start with three terms, if you factor something out, inside the parentheses you still have to have three terms, so be careful about that. So I think 2 times what is 2? Well, just 1. And then I think x cubed times what is x cubed? Again, just times 1, we wouldn't need anything. And then I think y squared times what would be y to the 8th. And again, since we have to add exponents, we would need a y to the 6th. So notice if I multiply 2x cubed y squared times 1y to the 6th, I'll get my first term. And then I just do the same thing. I think 2 times what is positive 6. Well, I would need a positive 3. I think x to the third times what would be x to the 4th. Well, again, since we add exponents, we would just need an x to the first. And y squared times 1 would be y squared. So I don't write the times 1 because it's going to be the same thing as 3x to the first anyway. And last but not least, I think 2 times what is positive 10. We would need a positive 5. I think x to the third times x to what power would be x to the 5th. Well, we would need an x squared. And then we would need, I believe, a y to the 8th power, because y squared times y to the 8th will give us y to the 10th.
Here's the way I like to think through these factoring problems involving the difference of two squares. First, make sure that you're dealing with a perfect square minus a perfect square. In this case, we are. So this binomial will factor as the product of two binomials. The first binomial will have a plus in the middle. The second binomial will have a minus in the middle. In the first position will be the factors of x squared that are the same. So x times x. In the second position will be the factors of 144 that are the same. 12 times 12. X plus 12 times x minus 12 is your answer, a factored version of x squared minus 144. It's important to be able to recognize your perfect squares, like 144. You might want to go back and review the perfect squares for the numbers 1 through 16.
Here in this lesson, we're going to go ahead and factor trinomial squares. There's a couple things that I would like you guys to pay attention to on this to make sure we fully understand it. Most of the time people look at a trinomial, as we can see here, and they would say, well, since this is a square root and that's a square root, it's a trinomial square. That's not always the case. This number right here always plays a big factor in it, and here's why. If we were to take the square root of x squared, let's go ahead and do that. So we have x squared, and we're taking the square root of it, that would equal x, right? So that means that that's a perfect square. Good, we need that. We also want to see if we can take the square root of 25. So we have to check to see if 25 is a perfect square. So if we take the square root of 25, that equals 5, which means it's a perfect square. Good. Okay, so we know that these two are perfect squares. Let me go ahead and erase this. And we know that the square root of x squared is x, and the square root of 25 is 5. So if we multiplied them together, we would get 5x. Now here's the key, and this is the main thing that makes it a trinomial square. We have to multiply the square root of this and the square root of this number, and we would get 5x, but then we also have to multiply that by 2. So if we multiplied it by 2, that would equal 10x. Now, why did we go through all that trouble? Well, because if we take the square root of this and this, multiply it, and then multiply it by 2, if it gives us the number that's in the middle, then we know that it's a trinomial square. You don't always have to go through those steps, but that's what you have to see to make it a trinomial square. So then what would our answer be? Well, our answer would be this. It would just be the square root of that, which is x, the square root of 25, which is 5, and since they're all positive, it would be a plus sign, and that would be a binomial, and we just square it. So that would be our answer. So again, you take the square root of that, and you take the square root of that. They have to be perfect squares. Then you go ahead and you multiply those square roots together, and then multiply it by 2. And if that will give you the number in the middle, then it's a trinomial square, meaning you can just put the square root of that right here, the square root of 25 right here, and put the quantity of that squared.
Hi guys, I'm Nancy, and I'm going to show you how to solve a quadratic equation by factoring. Okay, first we're going to look at a simpler one and just use a brute force method. And then I'm going to show you a tougher one where it's going to be faster and easier to use a trick called the magic X method, or X method. And that's for when the brute force method would take way too long. And this trick will absolutely give you your factors so that you can solve your equation. Okay, so say you have this quadratic equation that starts with x squared, and you need to solve it by factoring. Okay, so what you want is two factors, each starting with x, that multiply to your expression and equal 0. Okay, so what you need to do to factor is find two numbers that multiply to negative 16, your last number, and add to positive 6, your second number. So that's two numbers that multiply to negative 16 and also add to your middle number 6. So again, we're looking for two numbers that multiply to negative 16 and add to positive 6. So first what you need to do is make a list of all pairs of numbers that multiply to negative 16, and you can do that off to the side. So we want two numbers that multiply to negative 16. Let's list the pairs. We could have 1 and negative 16. We could have flipped signs, negative 1 and 16. We could have 2 and negative 8. Flip the signs, negative 2 and 8. We could also have 4 and negative 4, or the opposite, negative 4 and 4. Okay, so you've made a list of all numbers that multiply to negative 16. Now let's look at the other requirement. You need to find which ones add to positive 6. So let's check them. 1 plus negative 16 would add to some negative number, so that can't be it. Negative 1 plus 16 would give you positive 15. It's a bit too large. 2 plus negative 8 would give you negative 6. So it's close, but it's the wrong sign. Negative 2 plus 8 would add to positive 6. So those are your factor numbers. Now you don't need to check any pairs that are left. You can assume they're not right. You found your factor numbers negative 2 and 8. Okay, so now you've found your two numbers and you just need to fill them into your factors. So you found negative 2 and 8, so you simply put negative 2 here, positive 8 there.